Hello everybody, today we're going to take a look at another example at calculating the Laplace transform for certain functions. We're up to our third example, which is f of t equals t to the power n, some integer which is bigger than or equal to 1. Okay, so let's jump straight into our definition. The Laplace transform is defined as the integral from 0 to infinity of e to the minus st times little f of t, which is t to the n dt, and the infinity on the integral, so this thing here. Well, this is just the same as taking some limit. I'd like to use the letter big X. So it's the integral from 0 to big X. Take the limit as x goes to infinity. And we're doing this over the function e minus st tn dt. Okay, so now our attention should change to focusing on how are we going to integrate this function. Well, it turns out we're going to need the parts formula. So a quick reminder, what's the parts formula? Well, the parts formula says if you integrate some function which is a product, u times dv dx, you integrate this over x. Well, this is u, v, take away the integral of v du dx over x. Okay, so in our case, what we're going to do, we're going to let u be t to the n, and dv dt, because our x and t should change here, we're looking at the x variable representing time. So dv dt e to the minus st. Okay, so we want to put this into the parts formula. So we're going to need du dt and we're going to need v. Okay, du dt is n t n minus 1. To find v from dv dt, we need to integrate. And this is just a standard integral. We need to divide by the number in front of t, which is just minus s. Okay, so let's do it. Let's put all this in, see what happens. Let's go back. Now this gives, let's see it. Well, it's the limit as x goes to infinity, u times v. This is our u, this is our v, evaluated between 0 and x. Take away the integral of v du dx. So just drop everything in. And we're left with something that's quite large. Okay, let's take a look at the first term. So where should we start? The value t needs to go in somewhere. It's going in here and here. And big X needs to go in as well. So let's start with the big X. We have big X to the n e minus s big X over minus s. Let's put in 0. Well, that's obviously 0. So we just leave that one off. So we're on the limit as x goes to infinity of this. That's our first term. The second term, well, I think we need to do a bit of tidying up here. I can see there's a negative, and this integrals over t so I can take some constants out. I'm going to take out the n and the s, leaving me with t n minus 1 e minus st dt, and I need the limit to go to infinity, so I think I'll do it all in one go. Take it all in one go like that. This is x. Okay, so if I start here, I can see that x is getting very large, so my e here has a very large negative number which goes to 0, so that's very fortunate, and we're left with the second term, which is n over s. Take the limit as x goes to infinity of the remaining integral. Okay, so what patterns do we see here? Well, the first thing that jumps out to me is this thing here. Well, this is actually the definition of a Laplace transform for this function here. So actually what we can write is ns is the Laplace transform of Tn minus 1. Okay, so we don't have a final answer, but we do have something that's quite useful. We have the Laplace transform of t to the n is n over s times the Laplace transform of t to the n minus 1. And this is going to work for all the values of n. So the next thing we're going to do is use some induction. So by induction, so we're going to keep repeating this result. The Laplace transform for Tn, we just saw, is n divided by s times the Laplace transform for the power reducing by 1. Well, repeating the same idea this time for this part, we can see this is the same as, well, whatever's in the power, divide by s, the power is n minus 1, and then reduce the power by 1. And we can just keep going, keep repeating this process. We have n over s, n minus 1 over s, n minus 2 over s, all the way down, so on and so on, which is the same as n factorial over s to the power n plus 1. And this makes sense. Let's think about s similar to t, time, doesn't work for 0, so actually it works for any s bigger than 0. And the conclusion, after using this induction process, the Laplace transform for t to the n is n factorial over s to the power n plus 1. And this makes sense for any s bigger than 0. So there you go. That was a bit more involved, but still quite a nice answer at the end, I think.